In the world of chromatography, you must always be on the hunt for peak precision and peak efficiency. A key component to achieving your goals is identifying and integrating reliable screen media, such as a woven wire chromatography frit. These screening mediums are critical to the overall success of your chromatography. Thus, it is imperative that the design and construction of a woven wire chromatography frit is meticulous. But what exactly should you be mindful of when designing a woven wire chromatography frit? So there's several metal alloy options to choose from when selecting a sintered woven wire filter plate for column chromatography. And those options are 316 stainless steel, Hastelloy C22, and 904 stainless steel. Depending on your operation's needs, you can use any of these or even all three at once. But with these filter plates though, there are certainly cases when it comes to cost, less is more. Certain components of each have varying costs and are included to achieve operational thresholds. For example, you may require a filter plate that is extremely corrosion resistant and calls for a high nickel content. Now, there's more that makes up all of these, but for this simple cost exercise, we'll use the iron content as a counter measurement. So in that case, you'd be looking at, on average, for 316, you'd be looking at 12% nickel and 69% iron. For 904, it would be 21% nickel and 41% iron. And for Hastelloy C22, you'd be looking at 56% nickel and less than 3% iron. Now, at the time of making this video, the average cost of iron is about 4 cents per pound, and the average cost of nickel is $7.30 per pound. So as you can see, there's going to be a significant cost difference between these three different alloys. So, for example, if your process can be run by 316 stainless steel, it's likely that Hastelloy C22 can work, but it's probably not worth it. But be sure to investigate your process needs and share those with your material supplier to be sure that you've got the right alloy for your process. Opening size is going to be the other major factor when it comes to your filter plates. Opening size is going to be dictated by several factors, namely mesh count, wire diameter, and the number of layers. So mesh count refers to the amount of openings that are present in a linear inch. So, for example, a 4x4 mesh will have 4 directions in both directions of an inch. Wire diameter is simply the wire width used in the mesh and is placed after the mesh count in the material description. So by this reasoning, we can determine that a 10x10.02 has bigger openings than a 10x10.022 because the number of openings stays the same and the wire is smaller. And standard weaves, or plain weaves, have the same mesh count in both directions like the ones I was just talking about. But many multi-layered sintered filter plates use a filter weave for their filter layer, and these are a bit more complex. For example, you could see something like a 165 by 800, where in one direction you would have 165 openings and in the other direction you would have 800. And you'd have 2 different wire diameters. When it comes to plain weaves, it's generally pretty easy to infer the size of your mesh opening. But since filter weaves are a bit more complex, we're happy to provide any information you might need. It is critical that you fabricate your woven wire chromatography filter frit using a layer configuration that delivers the ideal balance between separation performance and flow rate. This requires you to consider parameters like mixture characteristics, size of the packing material, if applicable, properties of the frit, i.e. thickness and density. Multi-layer specifications are proven to do just that, improving flow distribution and optimizing separation efficiency. And you can determine the specifications of each layer and the number of layers. However, it is highly encouraged that you have, at a minimum, a coarse layer, an intermediate layer, and a fine layer. Thanks so much for watching. If you have any questions, click our Talk to Us button to get in contact with our many experts on woven wire. And if you'd like to learn more about woven wire mesh or our many products, we have a learning center filled with written and video content to make you an expert. We also have a YouTube channel. And don't forget to click that subscribe button and ring that bell to keep up with all things W.S. Tyler. Once again, my name is Andrew Kodlar, and I'll see you around in the next video. Bye for now.